Hello everyone and welcome to another video of Vivek Learns. So in this video series we will continue to solve some of the recursion problems of PepCoding that we had solved. In the last video we had solved this Tower of Hanoi equation that we had, and we had done the analysis where if we have two recursive calls, then we used to call this as the left call and this as the right call, and any area or code above this is called the pre-area. This is called the mid area between left call and right call, and whatever statements are present here, they will be called the post area. Okay, and we had drawn the Euler's diagram for this, and then we had traced the Euler's diagram to get the desired output that we want. So whenever we have two recursive calls, we can follow a similar approach and solve the problem. And one more observation that we had was whatever statements that are present after the recursive call, they will be executed when we are moving down the stack. And whatever statements are present before before the stack, so let's say if I have something like, yeah, so I have something like this, not this one, print increasing, yeah. So these statements will be printed when we are moving up the stack, and whatever statements are after this, they will be printed when we are traversing down the stack. So those two were the observations that we had made. So let us go back to the pep coding side where we have this introduction to recursion module. So we have solved all the problems of this module. So now let's try to solve the recursion arrays module that they have. The first question is display array. So you are given a number n representing size of an array. You are given number n numbers representing elements of an array A. You are required to print elements of an array from beginning to end, each with separate line. And we have to solve this using recursion. So let's try to solve this. So I create a class called, let me copy a class, print array or display array. Print array is fine. Let me open it. We take length, enter length of array, and then enter elements of the array. Then we can have a for loop. So we can have this variable as length here. Okay, we have a scanner dot next, and we have to create an array as well, right? So we create an array arr is equals to new int with the given length. We have arr of I, right? And we keep on incrementing I. This is how we'll get the array. And let me have this statement as print arr array. So yep. So what do we do? How do we solve it? So we'll follow the same steps that we had followed, right? So the first step was we set some expectations. And let's say that I have the expectation set that if I have, if I give print array, this print array method, array input and the index 5, like, and the size 5, not the index 5, then it will print all the elements of the array. So let's say we have the array ARR has 20, 21, 22, and 23. So the expectation is that, say one more element, 24. So the expectation is that p print array ARR and 5 in the, like, the length will print all the elements 22, 23, 24. And we can also have some faith. So the faith that we can establish is that when we have print array of 4, which is 1 less than 5, then we print 4 elements that we have: 20, 21, 22, 23. So how do we reach from the fate to the expectation? How do we do that? Fate to expectation. So what we can do is that we can invoke this print array first, and then we can print the last element, which is 24. So that is how we can achieve it, right? So in a generalized form, how do we write it? In a generalized form, we can write it as print array. Like, this can be the length, or let's call it n first, right? And this is nothing but system.out.println, right? Printing is nothing but having something like this: ARR of n minus 1, right? This is n minus 1 because n is the size of the array, right? And if we have ARR of n, then we will get index out of bounds exception, because the size of the array starts from 0 to n minus 1. So let's try to code this in. Okay, so let me have it here. Next int, right? Not next int ARR comma, what do we have it? Let me call it index, and we give ARR comma length. So whatever length we have, we pass it on. So we can first have a stack trace for this, and we can have a out of ARR of. Okay, so let's try to analyze this. We can have it in a paint, and we can. Okay, so let me open paint first. Let me open the stack diagram that I have handy, so we don't have to waste some time that goes on drawing that stack diagram. Let me open it in edit mode. Oh, we can't open it in edit mode. Can we open it from here? Edit with paint, something like that. Edit with paint 3D, but can we open it with paint? Yeah, we can, right? I'm not used to this Paint 3D, so yeah. So let me have this code here. So this will, let's consider this as the first line, this as the second line that we have. Okay, so at the first we'll have something like print array of, let us consider an array of ARR and of size 4, let's see. Yeah, okay. And here the index will be 4, right? Index is 4 here, right? Yep. So let me create an array here, ARR. So 20, 21, and 22, 23 with 4 elements. And once, like from the main method, this this is what it is. This is what is called print array of ARR, comma 4. And after this, what will happen is when the first line of this statement gets executed. Okay, let me have the first line here. When the first line is executed, we'll get something like print array of ARR, comma index minus 1. 4 minus 1 is 3. So here index is equals to 3, right? And when the first line of this statement gets executed, then what does happen? Again, a new method will be called with print array of ARR, comma 2. So here index is 2. And similarly, when the first line of this statement gets executed, again a method will be called with print array of ARR, comma 1. Here index value is equals to 1. So this will keep on going till something like this, right? And if we don't stop anywhere, this will keep on going. So we have to stop somewhere, and that is where we write the base case. So I think n is equals to 0 will be a good base case, right? So if n is equals to 0, then what do? We can print system.out.println, and then we can return. This is one thing that we can do. Or the second thing that we can do is that we can go one level further, and then we can return directly without printing in the if statement, right? So let's try to do that. Let's try to code in that. Yeah. So we will have an if statement which says if index is less than 0, then we should return. Okay, so what does diff do? So if we have index less than 0, your index is not 0. So we can have print array of arr, comma, -1. Your index is less than 0, which is -1, right? And when the first line, so before executing the first line only, we'll consider the base case. His base case is checked and we return from here. So what happens is we return from here. So we return from here. And then the second line is executed. And when the second line is executed, what happens is we, like, this is the second line, print arr of index -1. So the index is 0 here. So 0 minus 1. So 0 minus 1 is -1. So we'll get an index array out of bounds exception. So we can't return from here, is what I'm trying to say. So what do we do? So we must return from here. Okay. So if index is equals to 0, then we should return. So once we return from here, we come here. And then the second line is executed. So whenever the second line is executed, we print arr of index is 1 minus 1, meaning arr of 0. Arr of 0 is nothing but 20. Then this stack will be erased. So let me erase this one as well as erase this one because all the lines have been printed, right? And let me come here down and execute the second line here. So once this is executed, we'll print arr of 2 minus 1. 2 minus 1 is 1. So we'll print arr of 1, which is 21. Similarly, we can proceed further and we can print all the elements, right? So as all the statements of this method are executed, we return from here. And once we return from here, we fall down to the next method call that we have. So which will do arr of 3 minus 1 of 2. Arr of 2 is 0, 1, 2, which is 22. And finally, we'll have something like, so this second method, second statement is also executed, right? So we can erase that and we can return from here and return to this one. So here what happens is when the second statement is executed, we'll print ARR of 4 minus 1. 4 minus 1 is 3. So we print ARR of 3, which is 23. So this is how all the elements of the array will be printed, and after we print this entry in the stack is also be deleted. So I think it will run successfully. Let's try to run it. Oops, we run it again. 4 and then 21, 20, 21, 22, 23. Yep, all the elements of the array are printed. Yeah, so this was all for this video. Let's try to tackle the next question that we have. Not all for this video. This for all. This was all for this problem. So we have solved this question. Now let's try to solve in this one. Print arrays in reverse. Right. So this is the same question that we had solved for print array, but here we have to print the array in reverse order. That's the only difference that we have. So we'll have the same print reverse array, let's see. And we have this array. So we'll print 24, 23, 22, 21, 20. And we have established the faith that whenever we have print ARR of 2 minus 1, what do we do? We can print 24, 23, or we can have it in reverse, right? 23, 22, 21, and 20 gets printed, right? So what do we need to do is that we need to print the 0th element first. So print reverse array. Oops, my bad, we have to change this also, right? Print reverse array of um, ARR comma 4. So this will print all this. But before this, we need to print one element, which is 24. So the 24 is the 0th element. So just print 24, right? So this is how we'll go from this fate to the expectations. So how do we write it in a generalized format? So we can write it by invoking system.out.println here, and we can have the 0th element, or we can have the ARR of 24 is nothing but n, right? The 24 is nothing but the 0th element, right? Or the not the 0th element, but the last element that we have. So it is nothing but ARR of n minus 1, right? And then we simply call this with print array of n minus 1, right? We cannot have ARR of n because n is the length of the array and the index starts from 0 to n minus 1. So that is how we'll try to solve this question. Print array reverse, let's see. Take this import and we rename it to print array reverse. And the base case, let's think about the base case now. So we'll have the statements int, let me copy it from here, system.out.println, and then the ARR of, and then we can call this not n, we have index here, right? So this is how we will do it, right? We'll print this first, and then we'll call the recursive call that we have. So if you recall the thing that we had analyzed, or we had said in the in the start of the video, whatever elements are present before this will be executed when we are moving up the stack. And in the previous question that we had solved, print array, this statement was executed when we were down going down the stack. Correct? So now we'll go up the stack. So let's try to imagine this and so try to identify the base case here, right? So we'll go up the stack. So let's say we have an array of index 3, length 3, and we do ARR 2, then ARR 1, then ARR 0, and if we don't have any base case, we'll keep on going. So we need to stop somewhere. And where do we stop? So what if we stop at ARR of if we stop at index is equals to 0 and we return from there. So if index is equals to 0, then it will come here and it will fall where ARR comma and index is 1. So 1 minus 1 will give us 0, right? So ARR of 0. So that is how the 0th element will be printed. Um, right? Index minus 1. So we'll print ARR of index. Index will be 5, then 4, then 3, 2, 1, 0, right? If it comes to 0, then we return. Correct. So let me try to analyze this first again. ARR of n minus 1. If index is 0, then we return. What should be the base case? Yeah, this should be the base case, right? Because when index is equals to 0, then it will return from here and it will come here, and there are no statements after this. So this statement will be executed when we are moving up the stack. And then index is length first. So length minus 1, so the last element will be printed first, right? So let's try to validate this. 20, then 21, then 22, then 23, and then lastly 24. So we'll print 24, 23, 22, 21, hopefully. Yeah, because this statement is executed when we are moving up the stack, and when we return, there is nothing left to execute. So we go down the stack again, and then we just keep on falling because there are no statements that will be left to execute for the method. So that was all for this video. See you guys in the next one. Thank you.